Hi guys, I hope everyone's well today. In this video we will be going through the EdExcel GCSE Maths 9 to 1 paper from the higher tier, and it's from the June 2019 series. Question 1. We have a set of numbers. The numbers are 1, 2, 3, 4, 5, 6, 7, 8 and 9. A has the numbers 1, 5, 6, 8 and 9. B has the numbers 2, 6 and 9. And for part A of the question, we have to complete the Venn diagram to represent this information. The first thing I would like to do is find out which set of numbers belong in the union intersection. Those common numbers, you'd find those to be the 6. You'd also find the 9 as well. So what belongs to both? We have the 6 and the 9, and the 1, the 5 and the 8 go in the A only section. So here we have 1, 5, 8, and then we have the 2 which goes over here. The number which remains, we have the 3, we have the 4 and we have the 7. So we have 3, 4, 7. And now for part B of the question, a number is chosen at random from the universal set, and we have to find the probability that the number is in the set A and B. Well, over here we see that we have 9 numbers in total, and of those 9, 2 are in the set A and B. That's the 6 and the 9. So our probability therefore is 2 out of 9. Question 2. Katie invests £200,000 in a savings account for 4 years. The account pays compound interest at a rate of 1.5% per annum. We have to calculate the total amount of interest Katie will get at the end of the 4 years. Well, the first thing we can do is find out how much in total she has at the end of the 4 years, and then subtract this original £200,000 from that amount to work out the interest. So the total amount, to work out the total amount, we would have to use the formula original multiplied by our multiplier, which is 1 plus the percentage over 100, and we raise this to the power of t, which is our time frame, in this case 4 years. So we have our original amount, 200,000, and then we multiply this by 1 plus our interest rate, that's 1.5, and then we divide this by 100, and then we raise this to the power of 4. So if we work this out, 200,000 multiplied by 1 plus 1.5 over 100 to the power of 4, it turns out we get 212272.7101. Okay, and therefore the amount of interest that's accumulated, we subtract off 200,000 from this. So the interest is equal to 212272.7101 minus the 200,000. So therefore we get 12272.71. Okay, so here we have 12272.71 pounds. Now for question number 3, we've got this table over here which shows the information about the heights of 80 plants, and we have to find the class interval that contains the median. Well, the position of the median, that will be given by n over 2. So the median, we have 80 plants in total, divide that by 2, we want to find out the 40th value. And the way we can find the 40th value is to first of all find the cumulative frequency. And if we do that, we begin with the 7. 7 plus 13, that's 20, plus 14, that will be 34, plus the 12, that will be 46, plus the 16, that will take us up to 62, and adding on the 18, that will take us to 80. So the 40th value, that will lie in this interval over here. That is 40, which is less than h, which is less than or equal to 50. And now for part B of the question, on the grid, we have to draw a frequency polygon for this information. Before we do that, we need to first of all find the midpoints. So if we find the midpoint here is 15, here the midpoint is 25, here we have 35, here we have 45, here we have 55, here we have 65, we have the midpoints shown. So when we plot those, we want to plot the midpoint against the frequency. So let's do that. So here we have our frequency polygon, and notice I've plotted the midpoints against the associated frequencies. Question number 4. Sean has drawn a time series graph to show the numbers in thousands of visitors to a fun park. So we've got over here the year, and then we've got over here the number of visitors in thousands. And we have to write down two things that are wrong or could be misleading with the graph. First of all, the graph does not start at 0, it instead starts at 6, and the numbers on the horizontal axis are repeated, which is incorrect. Now for question number 5, the diagram shows a hexagon, and the hexagon has one line of symmetry. This one line of symmetry, that is over here somewhere. Okay, so let's just quickly add on this line of symmetry. We have here our line of symmetry. And we see that FA is equal to BC. We see that EF is equal to CD. And the angle ABC, that's 117 degrees, and the angle BCD, that's twice the angle CDE. And obviously I know my line of symmetry will be over here because FA is equal to BC. And if we have some sort of symmetry, then of course whatever is on the left of this blue line is going to be the same as what's to the right of this blue line. Now over here we've got to work out the size of angle AFE. So AFE, that's what we have to work out, and we have to show all our working. Well, if this angle over here is twice this angle, if I call this angle over here X, then by symmetry this is also equal to X. And if BCD is twice this angle here, this angle over here is equal to 2x. So we have 2x here and we have 2x over here. And then if we've got 117 degrees here, here we also have 117 degrees. And we can find out what x is by first of all finding the sum of all the interior angles of this shape, and then find an equation in x to solve for x. And with that we can from then find out what 2x is, which corresponds to the angle AFE. So first of all, the sum of the interior angles, that's equal to the number of sides. We have here a 6-sided shape, minus 2 multiplied by 180, and if we work this out we get 720 degrees. So all the angles add up to 720 degrees. In other words, we have 117 plus another 117 plus 2x plus 2x plus x plus x. All this is equal to 720 degrees. So we have here 234 plus 6x, which is equal to 720 degrees. 6x therefore if I subtract off 234 from both sides, 720 take away 234, that's 468. And now if I divide both sides by 6, 468 divided by 6, that's equal to 81. So x is equal to 81, and therefore the angle AFE, that's equal to 2x, as we said over here. So we have over here 2 lots of 81, which turns out to be 162. So AFE, that's 162 degrees. Question number 6. Jeremy has to cover 3 tanks completely with paint. Each tank is in the shape of a cylinder with a top and a bottom. The tank has a diameter of 1.6 meters and a height of 1.8 meters. Jeremy has 7 tins of paint. Each tin of paint covers 5 meters. We have to find out if Jeremy has enough paint to cover completely the 3 tanks. You must show how you get your answer. Well, what we can do over here, first of all, we can find out how much these 7 tins of paint cover, first of all. If each tin of paint covers 5 meters squared, 7 tins of paint will therefore cover 7 times by 5, which is 35. So the 7 tins of paint would cover 7 times by 5, which is 35 meters squared. We can now find the area of one tank and then multiply that by 3. So the surface area of one tank, well, we've got the circle. The area of the circle, that's pi r squared. So here we have pi times by the radius squared. The radius is half the diameter, which is half of the 1.6, which is 0.8. And then we multiply this by 2 because we've got the circle at the top and the circle at the bottom. And then for the curved surface area, we have pi times by the diameter times by the height. So here we have pi times by the 1.6 multiplied by the 1.8. And therefore, if we work all of this out, we have 2 pi multiplied by 0.8 squared plus pi lots of 1.6 lots of 1.8. It turns out we get 104 over 25 pi. So here we have 104 pi over 25 meters squared. And therefore, for 3 tanks, the surface area of 3 tanks, that will equal this value over here, 104 pi over 25, multiplied by 3. So if I multiply this by 3, I end up with 312 pi over 25 meters squared, which is the same as 39.207 etc. meters squared. Now this value over here is greater than the 35 meters squared, and therefore we can conclude that he does not have enough paint. For question number 7, we have to work out the square root of 25 times by the sine of 43 degrees divided by 8.2 squared minus 50.5. And if we substitute this into our calculator, we have the square root of 2.5 times by the sine of 43 degrees divided by 8.2 squared minus 50.5. We end up with a value of 0.3 319,141,9855, which to three significant figures we end up with 0.319. So we end up with 0.319 to three significant figures. For question 8, ABC is a right-angled triangle and AB has a length of 6 centimeters, AC has a length of 8 centimeters. You can first of all recognize over here that the largest side, that's 8 centimeters, so this 8 centimeters would correspond to the hypotenuse. So Sarah's method to finding out what BC is, that's AB squared plus AC squared, and straight away we can see this is incorrect, because what she should have done to work out the length of BC, that's the biggest side, which is AC squared, minus one of the short sides, that's AB squared. So in other words, BC squared is equal to AC squared minus AB squared. Now for part B of the question, Ro is going to enlarge triangle PQR with centre C and scale factor 1.5, and he draws triangle XYZ as a result of this, and we have to explain why Roy's diagram is not correct. Well, if we find the length over here of PQ, you'd find the length of PQ, that's equal to 2. And if you look at the length of XY, which corresponds to PQ, you'd find this length to be 5. And therefore, you can see here that the scale factor, that's equal to 5 over 2, which does not equal this 1.5. Okay? So therefore, we can say, in terms of what's wrong with his diagram, he's used the wrong scale factor. Question number 9. A company has to make a large number of boxes. The company has 6 machines. All the machines are working at the same rate. When all the machines are working, they can make all the boxes in 9 days. So this is if all the machines are working. And the table gives the number of machines working each day. So on the first day, there's 3 machines working. On the second day, there's 4 machines working. On the third day, there's 5 machines working. And for the other days, there's 6 machines working. We have to work out the total number of days taken to make all these boxes. Well, over here, the total number of days, we've got 3 days over here, plus all the other days. That would be the total number of days. And for us to answer this question, we actually need to find out what all the other days amount up to. Now, what's key in this question is that all the machines are working at the same rate. And the company has 6 machines. Okay? So, what does this mean? Let's just highlight this. The company has 6 machines. And when all the machines are working, they can make all the boxes in 9 days. So, in other words, 6 machines requires 9 machining days. Okay? So 6 machines require 9 machining days to make all boxes. Okay? Now, don't confuse the machining days with the days over here. Okay? They are 2 separate things. So 6 machines require 9 machining days to make all boxes, and therefore one machine, bearing in mind that the machines work at the same rate, one machine would therefore require 9 times by 6, which is 54 days. So one machine would require 54 machining days to make all the boxes. And that makes sense if you think about it, because over here if you think about it, a good way to explain this, you've got 6 machines which require 9 machining days. So one machine will take much longer than that, and if they work at the same rate, if 6 machines take 9 days, one machine will take 6 times longer than this 9 machining days. In other words, 9 times by 6 is 54, so we require 54 machining days for one machine to make all the boxes. Okay, hopefully that makes sense so far. Now, in the first 3 days, we see over here that we have 3 plus 4 plus 5 machines working. So in the first 3 days, there's 3 plus 4 plus 5, which is 12 machines working. In other words, we require 12 machining days for days 1, 2 and 3. And with this information, we now need to find out how many machining days we require for all the other days. So the remaining machining days, that's equal to 54 minus 12, which is 42. So we require 42 machining days for all of the days. Okay, hopefully everything I'm saying makes sense so far. So we require 42 machining days for all other days. Okay, and now we've got 6 machines working for all those other days, so therefore the number of days we require, so the number of days that's going to equal 42 machining days divided by the 6 machines working, which tells us we require 7 days. So what does this mean? We have 7 days over here in total. So therefore the total number of days we require, that's equal to the 1 plus the 2 plus the 3, so we have 3 days here, plus the 7 days. In other words, we require 10 days in total. Bit of a difficult question that, I think. Question 10. Marie invests £8,000 in an account for 1 year. At the end of the year, interest is added to her account. Marie pays tax on this interest at a rate of 20%, and she pays £28.80 tax. We have to work out the percentage interest rate for this account. So what's this telling us? We've got £8,000 over here, okay, in an account, and at the end of this year, interest is added. Now I don't know what this interest rate is. That's what I'm working out. Okay, so the percentage interest rate is what's added to her account. Now, with this interest rate, what's happening is 20% tax is being taken into account for this interest rate that she pays, and she pays this much tax. Okay, so we've got 8,000 times by the interest rate. Okay, so at the end of the year she's got a certain amount of money. And then what's happening is she's paying 20% of tax on this amount. So we've got 0.2, which corresponds to the 20%. So she's got 20% of this amount, and this is equal to 28.80. And our objective is to find out what I is. So we've got 8,000 multiplied by I, which is equal to 28.8 divided by 0.2, which is 144. So therefore I, that's equal to 144 divided by 8,000, which is 0.018. So this is the interest as a multiplier. So therefore, as a percentage, multiplying this by 100, we end up with 1.8%. Okay, so we have 1.8%. Question 11. In May 2019, the distance between Earth and Mars was 3.9 times 10 to the 7 kilometers. In May 2019, a signal was sent from Earth to Mars. Assuming that the signal sent from Earth to Mars travelled at a speed of 3 times 10 to the 5 kilometers per second, we have to find out how long it took the signal to get to Mars. Well, here we have a speed, here we have a distance, we're finding out the time. Of course, speed is equal to distance divided by time. We're working out the time, so the time, that's equal to the distance, 3.9 times 10 to the 7, divided by the time, divided by the speed, which is 3 times by 10 to the 5. So the time, therefore, in seconds, we have 3.9 times 10 to the 7 divided by 3 times by 10 to the 5, which is 130. So we have 130 seconds. And now for part B of the question, the speed of the signal sent from Earth to Mars in May 2019 was actually less than 3 times 10 to the 5 kilometers per second. How will this affect our answer? Well, if this number here is smaller, so if we go back to our calculator, if we choose a smaller number, say 2 times 10 to the 5, we get a time which is greater. And that makes sense if you think about it. The slower we're travelling, the longer it will take. So, in other words, it will take longer. Now for question number 12, Patrick has to work out the exact value of 64 to the power of 1/4. And Patrick says 1/4 of 64 is 16. So therefore, 64 to the power of 1/4 is 16. Explain what Patrick has done wrong. Well, if we work out 64 to the power of 1/4, that's the same as the 4th root of 64. So in other words, he needs to work out the 4th root of 64, which is 2 times by the square root of 2. Question 13. The density of ethanol is 1.09 grams per centimeters cubed. The density of propanol is 0.97 grams per centimeters cubed. 60 litres of ethanol are mixed with 128 litres of propanol to make 188 litres of antifreeze. You have to work out the density of the antifreeze. Give your answer correct to 2 decimal places. Well, what connects the density, the mass and the volume is this formula here. Density is equal to mass over volume. So with this, we've been given the density of ethanol, we've been given the volume of ethanol, so therefore with this we can work out the mass of ethanol by multiplying the density and the volume. So the mass of ethanol, that's equal to 1.09 multiplied by 60. So if we work this out, 1.09 times by 60, that's equal to 65.4. So we have 65.4 grams. We can do the same thing with propanol. So the mass of propylene, so let's just work this out. That's going to equal 0.97 multiplied by the 128. So if I work this out, 0.97 times by 128, that's equal to 124.16. So therefore the mass of antifreeze, that's equal to 65.4 plus the 124.16. So if I work all of this out, we end up with 189.56 grams. Okay, so with that we can find out the volume of antifreeze. We know the volume of antifreeze, that's 188. So with this we can find out the density. So therefore the density of antifreeze, that's equal to density is equal to mass over volume. So here we have the mass, which is 189.56, divided by the volume, which is 188. So if I work this out, 189.56 divided by 188, that's equal to 1.008 grams per centimeters cubed. So therefore to two decimal places we have 1.01 grams per centimeters cubed. Question 14. The diagram shows a rectangle ABDE and two congruent triangles AFE and BCD. We've got this angle here which is equal to 30 degrees, and we've got this angle over here which is equal to 30 degrees. This length here 24 centimeters, this length over here also 24 centimeters. The area of this rectangle, that's equal to the area of this triangle here plus this triangle over here, and we know that AB to AE is in the ratio 1 to 3. Okay, so to work out the length AE, we can first of all use this ratio here. If AB to AE is equal to 1 to 3, we're working out AE, so let's just call this length X. Okay, well before we do that actually, let's use this ratio here. From here we can see that AB over AE, that's equal to 1/3. So therefore we can hopefully see here AE, that's equal to 3 times by AB. So if the length of AB is equal to X, the length of AE, that's equal to 3x. And if we solve for x, multiplying that by 3 will allow us to find AE. So with this we can find out the area of the triangle. So the area of AFE, that's obviously equal to the area of BCD. So working this out, we have a half times by 24 times by 3x times by the sine of 30. So if we work all of this out, we end up with 18x centimeters squared. Okay, so the area of ABDE, that will equal the area of the rectangle x times by 3x. So here we have x times by 3x, and this is equal to the area of this triangle here plus this triangle here. So here we have 2 times by 18x. So we have 3x squared equals 36x. X squared is equal to 12x. So we have x squared minus 12x, which is equal to 0. Factorising, we have x lots of x minus 12, which is equal to 0. So in other words, x is equal to 12. And therefore the length AE, that's equal to 3x. So here we have 3 lots of 12, which is 36. So we have AE, which is equal to 36 centimetres. Question 15. The graph of the curve C with equation y equals f of x is transformed to give the graph of the curve S with equation y equals f of minus x minus 3. And the point on C with coordinate 7, 2 is mapped to the point Q on S. We have to find the coordinates of Q. First of all, going from y equals f of x to y equals f of minus x minus 3, this is a reflection in the y-axis, so that corresponds to the f of minus x, followed by a translation by vector 0, minus 3. So that corresponds to this minus 3 here. So if we reflect in the y-axis, the x-coordinate of q, that's going to equal minus 7. So that corresponds to multiplying the 7 by minus 1. And the y-coordinate of q, that's going to equal 2 minus 3, which is minus 1. So in other words, the coordinates of q, we have minus 7, minus 1. Question 16. Here are the first 6 terms of a quadratic sequence. We have minus 1, 5, 15, 29, 47 and 69. We have to find an expression in terms of n for the nth term of this sequence. First of all, we can find the difference between each term. So the difference between each term here, we have 6, 10, 14, 18 and 22. We can then find out the difference between each of these terms. So the difference between each of these terms is 4. So therefore, to find out the coefficient of a, remember a quadratic sequence is going to be of the form an squared plus bn plus c. To find the value of a, we simply divide the second difference by 2. So we have 4 divided by 2, which is equal to 2. So therefore, a is equal to 2. My next step is to write down the n squared terms. Minus 1, 5, 15, 29, 47. My next step, is to write down the n squared term. So here we have 1, 4, 9, 16, 25, 36. My next step will be to work out the 2n squared terms. 2 times 1, that's 2. 2 times 4, that's 8. 8 times 9, that's 18. 16 times by 2, that's 32. 25 times 2, that's 50. 36 times 2, that's 72. My next step will be to write down the sequence. So for the sequence we have minus 1, 5, 15, 29, 47 and 69. And my final step is to work out the difference between the sequence and the 2n squared terms. Minus 1 take away 2, that's minus 3. Here the difference is also minus 3, as shown here. To find out the b term, I find out the difference between each of these terms. So the difference between each of these terms is 0, as we see here. So therefore, b is equal to 0. And to find the 0th term, we simply do the opposite of adding 0, which is subtracting 0. So here we end up with minus 3. Okay, so therefore c, that's equal to minus 3. And substituting these in, we see that our nth term will be given by 2n squared minus 3. Question 17, we've got 4 graphs as shown here, and we have to match the description of the function in the table to the letter of each graph. So f of x is inversely proportional to x, so that would represent the graph of y equals 1 over x, which is this graph over here, graph B. F of x is directly proportional to the graph y equals square root of x, so here that would correspond to y equals square root x. That would correspond to graph C. An exponential function, that's graph D, and therefore this one is a trigonometric one. It's actually the graph of sine, because it follows the shape of sine. Question 18, we have to show that 2x plus 1, lots of x plus 3, lots of 3x plus 7 can be written in the form ax cubed plus bx squared plus cx plus d, where a, b, c and d are integers. Well, we've got this 2x plus 1, and if I multiply the x plus 3 and the 3x plus 7, we end up with 3x squared plus 16x plus 21. Our next step is to multiply all these terms out. 2x times by 3x squared, that will be 6x cubed. 2x times by 16x, that will be 32x squared. 2x times by 21, that will be 42x. 1 times by 3x squared, that will be 3x squared. 1 times by 16x, that's 16x. 1 times by 21, that's 21. Collecting like terms, we have 6x cubed, 32x squared and another 3x squared, that's 35x squared. 42x and another 16x, that's 58x. And then we've still got this 21. For part B, we have to solve 1 minus x all squared being less than or equal to 9 over 25. So here we've got 1 minus x, which is less than the square root of 9 over 25, which is plus minus 3/5. So here, if I deal with the positive, we see that x is greater than, if we deal with the positive first, write it out in full. We've got 1 minus x being less than 3 over 5. So we've got x which is greater than 2/5. And if I deal with the negative, we've got 1 minus x which is less than minus 3/5. So we've got x minus 1 which is greater than 3/5. So therefore x is less than 8 over 5. So therefore, combining these, we end up with 2/5, which is less than x, which is less than 8 over 5. Question 19. D is equal to u squared over 2a. U is equal to 26.2, correct to 3 significant figures. A is equal to 4.3, correct to 2 significant figures. We have to work out the upper bound for the value of D. Give your answer correct to 6 significant figures. You must show all your working. Okay, so for us to do this, we can first of all work out the upper bound of u, which is equal to 26.35. The lower bound of u, that's equal to 26.25. The upper bound of a, that will equal 4.35. And the lower bound of a, that's equal to 4.25. If we combine these, the upper bound of d, which is what we need to work out, we want d to be as big as possible, so that's going to equal the upper bound of u squared over 2 lots of a. We want the lower bound of a to make d as big as possible, so we have 2 lots of the lower bound of a. So if we work this out, we have 26.35 squared divided by 2 lots of 4.25, and if we work all of this out, 26.35 squared divided by 2 lots of, so I'll write it out as a fraction, divided by 2 lots of 4.25, we end up with, have I done this right, 26.235 squared divided by 2 lots of this. Sorry, over here I've got these wrong. So this is 2.5, this is 1.5. So here I'm supposed to have 2.5. So I end up with 81.06, etc. So therefore, to 6 significant figures, we end up with 81.0661. So here we end up with 81.0661. Okay. Now for part B, the lower bound of the value of d is 78.6003, correct to 6 significant figures. By considering bounds, we have to write down the value of d to a suitable degree of accuracy. You must give a reason for your answer. Well, if we've got this lower bound and this upper bound, d is going to be somewhere in between these. Okay? And you can see that both 78.6003 and 81.0661 both round to 80. So therefore, d is equal to 80 because the bounds agree when rounded to 80. This rounds up to 80, this rounds down to 80. Question 20, we have to solve algebraically the simultaneous equations x squared minus 4y squared equals 9 with 3x plus 4y equals 7. Well, we can't just simply add these equations together because here we've got a 4y squared and here we've got a 4y. So instead, the way we approach this question is to eliminate one of the variables and then substitute into the quadratic. So if I call this equation 1, this equation 2, looking at equation 2, that's the linear equation. So from equation 2, we can see that 3x is equal to 7 minus 4y, so therefore x is equal to 7 minus 4y divided by 3. We'll call this equation 3. And now if I substitute in equation 3 into equation 1, we've got x squared, so here I've got 7 minus 4y over 3 squared, minus 4y squared, this is equal to 9. So over here, 7 minus 4y over 3 squared, that's going to be the same as 7 minus 4y all squared, and the 3 squared, that's 9. And then we subtract off 4y squared, and this is equal to 9. And if I multiply through by 9, so timesing through by 9, we have 7 minus 4y squared minus 36y squared, that's equal to 81. And if we expand the 7 minus 4y all squared out, we end up with 49 minus 56y plus 16y squared minus 36y squared. This is equal to 81. So we have minus 20y squared minus 56y minus 32 equals 0. And if I divide this now by minus 4, we end up with 5y squared plus 14y plus 8 equals 0. So here we have plus 8, and this is equal to 0. So to solve the y is equal to, using the quadratic formula. So here we've got minus 14 plus minus 14 squared minus 4 lots of 5 lots of 8 square rooted divided by 2 lots of a. So if we work this out, we've got minus 14 plus the square root of 14 squared minus 4 times by 5 times by 8 divided by 2 times by 5, which is minus 4/5. So that's one solution. And for the other solution, we can change this to a minus. We end up with minus 2. Okay, so now all we have to do is substitute these values of y back into our x equation. So when y is equal to minus 2, x that will equal 7 minus 4 lots of minus 2 divided by 3. So if I work this out, 7 minus 4 lots of this divided by 3, that's going to be 5. And when y is equal to minus 4/5, x is going to equal 7 minus 4 lots of minus 4/5 divided by 3. So if I work this out, 7 minus 4 times by minus 0.8 divided by 3, we end up with 17/5. So our solutions, therefore, we have x equals 5, y equals minus 2, and we also have x equals 17/5, y equals minus 4/5. So those are our solutions to these simultaneous equations. Question 21. The histogram gives information about the distribution of the weights of some onions grown by a farmer. So we've got the frequency density and the weights. And onions less than 60 grams in weight are used for pickling. Onions greater than 120 grams, those are sold at the market. The rest of the onions are sent to a food processing factory. And we've got this pie chart over here, which shows the a pie chart is drawn using the information opposite to show what the farmer does with the onions he grows. So that just basically repeats what he said, but in pie chart form. And the angle of the sector for the onions sent to the food processing factory is x. We have to work out the value of x. Well, for this, we need to work out the frequency, the total frequency, and also work out the amount that corresponds to the onions that are sent to the food processing factory. And to do that, we need to make use of the formula that relates the frequency density to the class width. Of course, that formula, frequency density multiplied by the class width, gives the frequency. So the frequency over here, 60 multiplied by 2, you'd find that to be 120. 30 multiplied by 5, that would be 150. 30 multiplied by 9, that will be 90. And then here we've got, as it looks like, we've got 15 multiplied by 6. What am I talking about? 15 multiplied by 6, that's 90. So over here, this corresponds to 90. And here, 45 multiplied by 2, that's 90. So therefore the total frequency, in other words, the amount of onions we've got, that's going to equal 120 plus 150 plus the 270. Sorry, this is 270 rather. So here we have 270 plus 90 plus another 90. This is equal to 720. Okay, so the amount we've got therefore in between 60 and 120, so these are the ones that are sent to the processing factory. So the factory frequency, that's equal to the 150 plus the 270. So here we have 150 plus 270. This turns out to be 420. So therefore the angle X, that's equal to 420 divided by 720. So this is the proportion that are sent to the processing factory, and then to work out the angle we multiply by 360, so we have a half times 420, which is 210. So therefore we have 210 degrees. Okay. For question number 22, we've got the diagram which shows a circle with centre O, as we see here, and AB is a tangent to the circle at the point A. The point B has coordinates 16, 0. The point P has coordinates 3P and P. We have to find the value of P to one decimal place. Well, if we have a tangent to the circle, the tangent meets the radius at 90 degrees. So what does this mean? Well, it means over here that here we've got our radius and they meet at 90 degrees. Okay, so this over here is our radius. From a center to a point on the circle, that's also the radius. So let's show this. So this over here is also the radius. And in fact, we can find out what this is using Pythagoras in terms of P. We can find the radius in terms of P, and we can also find the actual value of the radius. Why can we do that? Because you'll notice the length OB, so the length O to B, that's equal to 16. So 16, that corresponds to the hypotenuse. OA, which is the radius, that corresponds to the opposite. So here we have the sine of 30, which is equal to OA divided by 16. So therefore OA, that's equal to 16 sine 30, which is 8. So in other words, the radius is equal to 8. And if we use Pythagoras over here, we have OP, which is equal to 3p squared plus p squared square rooted, which turns out to be the square root of 10p squared. Okay? So this over here corresponds to the radius. So in other words, the radius, which is equal to 8, is also equal to 10p squared square rooted. So we have 10p squared square rooted, which is equal to 8. 10p squared, that's equal to 64. P squared, that's equal to 6.4. And therefore, square rooting, we see that p is equal to the square root of 6.4, which is 2.52, etc. So therefore, we have to, one decimal place, 2.5. Question number 23. The diagram shows the positions of 3 towns A, B and C, and B is 8 kilometers from A on a bearing of 37 degrees. C is 9 kilometers from B on a bearing of 150 degrees. We have to work out the bearing of C from A. You must show your work and give your answer to 1 decimal place. Well, for bearings we have 3 figures and it's measured from north. And we're measuring from A to C. So in essence what we want is this. We've got AC and we want this angle over here. Because remember, bearings are measured from north. And for us to work out this total angle, we need to first of all work out this angle here. We'll call it theta. Now, the way we can approach this is, if I know what AC is, I can use the sine rule to work out this angle theta. But before that, what we can also do is, if I extend this line, I know that angles on a straight line add up to 180. So this angle over here must equal 30 degrees. And therefore, this other angle remaining, we have alternate angles, so this angle over here is 37 degrees. So with this, we can find out the length AC. AC squared, that's equal to, using the cosine rule, 8 squared plus 9 squared minus 2 times by 8 times by 9 times by the cosine of 37 plus 30 degrees. So if we work this out, we have 8 squared plus 9 squared minus 2 times by 8 times by 9 times by the cosine of 37 plus 30. It turns out we get 88.7, etc. So therefore AC, that's going to be the square root of this, which is 9.419, etc. So let's store this into A. So here we have 9.419, etc. So therefore, using the sine rule, we have the sine of theta over 9, and this is equal to the sine of 37 plus 30 over this 9.419, etc. So we can rearrange for sine theta. So we have over here the sine of 37 plus 30 divided by this value, and then multiply this by 9. We end up with 0.87, etc. So theta, that will equal the inverse sine of this, which is 61.5, etc. So therefore the bearing, that's equal to the 37 degrees plus this 61.5, etc. So if I add on 37, I end up with, to 1 decimal place, 98.6 degrees. Okay, to 1 decimal place. So we end up with 98.6 degrees. Okay.